Hi, here's my midterm presentation. Good morning. Today, I'll introduce a system called AI Article Q&A system. This system is designed to combine a traditional article publishing platform with artificial intelligence techniques. The idea is simple that uh, pow- using powerful large language models, we enable users upload artificial intelligence about social events or news. Then other users can ask questions about these articles. Instead of only reading one perspective, the AI system will help users to understand different perspectives and verify facts. In addition, an AI agent in the system will automatically perform fact-checking on uploaded articles before they are published. The goal of this system is to improve the quality of online information and help people understand events more objectively. This presentation will cover four main parts. First, the background and motivation. Second, the system engineer lifecycle. Third, the technical architecture. And fourth, the challenges and future development. So let's first talk about the background. 100 years ago, most news comes from large newspaper organizations. These organizations employed professional journalists who investigate uh, events before publishing reports. Before Because of this process, the publisher tends to trust these news sources. As a result, the social often shared a common understanding of facts. However, the situation today is very different. With the rise of internet and social media, anyone can publish information online. While this increased freedom of expression, it can also create several problems. First, information is highly fragmented. People often read only content that supports their own views. Second, discussions online are often emotional rather than rational. Third, misinformation and false claims can spread very quickly. Because of these problems, it can become difficult for people to reach agreement about basic facts. The AI article Q&A system aims to address these issues. The platform encourages users to understand different perspectives. When someone reads an article, they can ask the AI system questions such as what's the opposite viewpoint, what's the evidence supports this claim, are there other sources discussing this event. At the same time, the system includes an AI fact-checking agent that analyzes the article and verifies their source before publication. The long-term version of this build a platform where people can share knowledge, explore different viewpoints, and reduce emotional conflicts in discussions. These concepts form the foundation of the system. Now let us look at the system engineering lifecycle. Development of AI article Q&A system can be divided into three major stages. The first stage is conceptual development. In this stage, we analyze users' need and define the basic system concept. The main user needs to include understanding facts about social events, exploring different perspectives, and reducing emotional bias in discussions. Based on these needs, we define the core function of the system. The second stage is engineering development. In this stage, the concept is transformed into a work system that the system is implemented as a web platform based on Java Spring Boot. In this platform, it allows users to authentication, article publishing, and the database storage in the AI integration. The third stage is deployment and operation. After deployment, the system is deployed online and maintained continuously. This stage includes several management, performance, monitoring, and future upgrades. The overall system architecture combines several technologies, including Java Spring Boot for backend service, MySQL for data storage, AWS 3 for file storage, and artificial intelligence models for question answering and fact checking. This structure allows the system to support a large number of users while maintaining reliability and scalability. Next, I'll explain the technical architecture of the AI system. The core AI functionality is based on the technique called retrieval augment generation, often called RAG. This architecture works in several steps. First, when the user uploads an article, the system can divide the article into smaller segments. Um, and each chunk is converted into a numerical representation called an embedding. These embeddings allow the system to make sure the semantic similarity between text segments. Second, when the user asks a question, the system can convert the question into an embedding as well. The system then searches the database for the most relevant article chunks. This process is known as top K retrieval. Third, the retrieved chunks are sent to a large language model as context. The model generates an answer based on this information and includes references to original articles. This process allows the system to answer questions while maintaining a connection to real sources. Another important component in the AI fact checking agent is that before an article is published, the AI agent analyzes the article and searches the internet for supporting evidence. If the system detected factual errors or unreliable resources, the article may be rejected. This ensures that most published content is based on the verified information. The system architecture includes several subsystems: user authentication and authorization, article storage and indexing, embedding generalization and similarity search, large language model API integration, and fact-checking AI agent running on the cloud server. Together, these components create a full-stack AI-powered knowledge platform. Now let's talk about cost and feasibility. Now let us discuss feasibility and cost. One important question is that whether this system is practical to build and to operate. Fortunately, many of the required technologies are already mature. Large language models are widely available APIs for providers such as OpenAI, Google, and other cloud platforms. Vector search techniques such as embedding similarity also widely used in modern AI systems. According to cost estimation, embedding an article of about 500 words costs approximately 1 cent. Answering a user question costs only a very small fraction of a cent. However, the fact-checking agent is more expensive because it requires multiple searches and model calls. The estimated cost for fact-checking is a single article is about 50 cents. To address this cost, the system can adopt two revenue strategies. First, advertisement revenue from the website traffic, because we believe that there is a large market that users want real facts instead of fake news on the website. So we believe that this website can have a tons of traffic, and our cooperation can gain revenue from the web traffic with advertisement and the users could understand why we have advertisement since the operation of artificial intelligence and AI agent fact checking is costly and well known to be costly. Second, selling verified fact checked articles to other organizations, such as media companies or research institutions. With AI agent doing fact checks, uh, those verified articles can be valuable for other companies to based on and doing research with fact news are very important for the researchers. Although the system is feasible and several challenges remains. The first challenge is model hallucination. Hallucination is well known to be exist since large language model has been invented since 2022. OpenAI published their GPT-2, and there is hallucination till now. Hallucination is inevitable. Large language models sometimes generate information that sounds reasonable but is actually incorrect. Even with RAG, this problem cannot be completely eliminated. The second challenge is latency. The RAG pipeline includes multiple steps such as embedding generation, similarity search, and model inferences. Each step adds delay. For good user experience, the response time should be ideally remain within 5 to 10 seconds. The third challenge is scalability of vector search. When the number of article chunks grows to hundreds or hundreds of thousands, similarity calculation becomes computationally expensive. Possible solutions include spectrally vector database or improved indexing. Another challenge is coordination between multiple development teams. The system involves background development, database design, AI integration, user interface design, and the DevOps infrastructure. These teams must coordinate closely during the development. And here comes the future development. With future development, we are expecting new AI models that is very competitive and better than nowadays AI models. This can support our AI-based fact-checked platform more useful and make the fact check better. And back to vector databases. There are tons of researchers that deal in databases research, so we believe that they can employ better vector databases in a near future. Third, the improved reasoning systems. Since OpenAI have published the O1 reasoning system, the artificial intelligence has better improved the reasoning systems. With the AI agent innovation, the reasoning system has been evolved since 2025, and we believe that in the future the reasoning system can be more developed and can be used in many other cases, so solving a fact check problem will not be very hard. And continuous system upgrades is expected for this project, and it will provide the users better experience in the near future. Here's the conclusion. The AI article Q&A system is an innovative platform that combines traditional article publishing with artificial intelligence. The system allows users to explore different perspectives, ask questions about articles, and verify factual information. Using technologies such as RAG, large language models, and AI agents, the platform aims to improve information quality and encourage more rational discussion online. Although challenges such as hallucination, latency, and cost remain, the system demonstration how AI can help build a more reliable knowledge sharing environment. Thank you for listening, and here ends my presentation.